Hello and welcome to my channel. In this video we will solve problem 1 and 2 of exercise 11.1 of 12th class maths. The first problem is, if a line makes angles 90 degree, 135 degree, 45 degree with the x, y and z axes respectively, find its direction cosines. So it is given that a line makes angles 90 degree, 135 degree, 45 degree with the axis. We have to find the direction cosines of the line. Let us start and solve the problem here. So solution, we have to take a line with this condition which is given to us. So let L be a line making an angle 90 degree, 135 degree, 45 degree with the axis x, y and z axis respectively. Okay, so the direction cosines of the line will be cos 90 degree, cos 135 degree, cos 45 degree. Okay, so therefore the direction cosines of line L are cos 90 degree, cos 135 degree and cos 45 degree. Okay, so that is cos 90 is 0, cos 135 we have to find out, and cos 45 is 1 by root 2, right? So let us find out cos 35. So cos 135 degree. So for this we will use all silver teacup concept. So this is the y axis, this is the x axis. Okay, so this is y axis, this is x axis, this is origin. Okay, then this is 0 degrees, this is 90 degrees, then 180 degrees here, 270 degree, okay, and then 360 degree. Okay, so this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Here all ratios are positive, here sine is positive, here tan is positive, here cos is positive, so all silver teacup. Okay, then whenever we go from x axis to any quadrant, the ratio remains same. Okay, whenever we go from x axis to any quadrant, whenever we go from y axis to any quadrant, the ratio becomes opposite. Okay, now you can write 135 as, so cos 135 we can write it as 180 degree minus 45 degree, right? So we are going in the second quadrant, 180 minus 45. Now in the second quadrant the sine is positive and cos is negative, so what we will get is negative. Cos will remain cos because whenever we go from x axis to any quadrant, the ratio remains same, so cos, and this angle theta we have to write it without this sign, so that is 45 degrees. Okay, so this is equal to minus cos 45 is 1 by root 2, so cos 135 is minus 1 by root 2. Okay, so that is 0 cos 135 is minus 1 by root 2, and this is 1 by root 2. Okay, so this is the answer of the first problem. So now let us go to the next problem, second one. Now let us look at the second problem. Find the direction cosines of a line which makes equal angles with the coordinate axis. So we have to find the direction cosines of a line which is making equal angles with the x-axis, y-axis and z-axis. So let us solve this problem. Solution. Let L be a line which makes equal angles with the x-axis, y-axis and z-axis. Okay, now what we will consider is angles made by line L with the x, y and z axis. So let alpha, beta and gamma be the angles made by L with the x, y and z axis. Okay, now since line L makes equal angles with the x, y and z axis, therefore what we get is alpha is equal to beta is equal to gamma. Okay, now we know this identity, cos square alpha plus cos square beta plus cos square gamma equal to 1. Okay, the sum of squares of direction cosines is equal to 1. So we know that cos square alpha plus cos square beta plus cos square gamma is equal to 1. So since alpha, beta and gamma are equal, we will get cos square alpha plus cos square alpha. So beta is equal to alpha, so we can write alpha instead of beta. Also gamma is equal to alpha, so instead of gamma we can write alpha equal to 1. So this implies this is 3 times cos square alpha, so 3 times cos square alpha equal to 1. So this implies cos square alpha is equal to 1 by 3. So that means cos alpha is equal to plus or minus root of 1 by 3. So that is plus or minus 1 by root 3, right? Now since alpha is equal to beta is equal to gamma, what we will get is cos alpha is equal to cos beta is equal to cos gamma. That is, if the angles are equal, then their cos is also equal, right? So this implies now plus or minus 1 by 3 plus or minus 1 by root 3 is equal to cos alpha. So plus or minus 1 by root 3 is equal to cos alpha, which is equal to cos beta, which is equal to cos gamma. Okay, so that means what we will get is, that is cos alpha is equal to plus or minus 1 by root 3. Then cos beta is equal to plus or minus 1 by root 3, and cos gamma is equal to plus or minus 1 by root 3. Okay, so therefore the direction cosines of line L are plus or minus 1 by root 3, plus or minus 1 by root 3, and plus or minus 1 by root 3. Okay, so this is the answer. So that's it in the video. If you have liked the video, please hit the like button. If you have not subscribed my channel, please do subscribe. I will see you in the next video.